Hi, thanks for joining me today. I'm going to be going over a really interesting integral. It's the integral from 0 to infinity of x times inverse tan of x, all divided by 1 plus x to the 4 dx. Now, you might be able to evaluate this integral using complex numbers, but actually the way I'm going to be showing you involves no complex numbers whatsoever. It's a really, really nice technique. Let's dive right in. Okay, so I've written up the integral that we're trying to evaluate up here, and I've also written a fact up here. And that fact is that the derivative with respect to x of the integral from 0 to x of f of t dt equals f of x. So this is a pretty standard fact, just comes from the fundamental theorem of calculus. And in fact, we can take one step further with this fact and actually kind of change this upper limit of our integral to an arbitrary function of x and get that the derivative from 0 to g of x of some function f of t dt, this would just be f of g of x multiplied by the derivative of x. So we're just applying this fact up here and using the chain rule to get this result here. So do stop to think about why these rules are true if you've not seen these before, but I'm just going to dive into using this to help me evaluate this integral. Okay, so what I'm going to do is define a function of x. It's going to be I of x, and this is going to be the integral from 1 over x to x of basically this thing here, but obviously I can't use x again, so t times inverse tan of t all over 1 plus t to the 4 dt, like so. And so this is definitely just a function of x, and what we're trying to do is basically work out what is I of infinity, or as I take x to approach infinity, what would I infinity be equal to? And that would be the same as the value of this integral. Okay, so we're considering this function here, and now I can just split this up as the integral from 0 to x of this function, so t times inverse tan of t all over 1 plus t to the 4 dt, and then take away the integral from 0 to 1 over x of the same thing, so t times inverse tan of t over 1 plus t to the 4 dt, like so. Okay, good. You can probably guess what I'm going to do next, given that I've written these facts up here. I'm going to differentiate through this. So if I differentiate I prime of x, what do I get here? Well, this is just using the pink fact, the fundamental theorem of calculus. So that would just be x times inverse tan of x over 1 plus x to the 4. And then this guy here is going to be minus the derivative of this, which is now means I need to use this fact here. So it's going to be f of g of x. So this thing inside, I'm just going to replace all the t's with 1 over x. So it's going to be 1 over x times inverse tan of 1 over x, all divided by 1 plus 1 over x to the 4. And I need to multiply that by the derivative of g prime of x. Well, g of x, sorry, the derivative of g of x. G of x is 1 over x in this case, so the derivative is minus 1 over x squared. Okay, cool. Well, I want to neaten this up a little bit. They look kind of similar, these terms. Well, I can firstly put those two minus signs together to give me that. And now with this second term, well, I'm going to multiply the top and bottom by x squared. And if I do that, I get x. This first term stays the same, x inverse tan x over 1 plus x to the 4. Plus, and then this term here is, once you simplify it, is just going to become x inverse tan of 1 over x all over 1 plus x to the 4. So I've just multiplied the top and bottom of this expression by x squared, because here there's already an x squared, so if I multiply by another x squared, I get x to the 4, times this denominator here, it gives me x to the 4 plus 1, and if I multiply the numerator by x squared, 1 over x just becomes x. And now these terms here look very, very similar. In fact, this is just x divided by 1 plus x to the 4, and then I've got tan inverse x plus tan inverse 1 over x. But tan inverse x plus tan inverse 1 over x, in fact, is always going to be just pi over 2. And you can think about this by just drawing a right-angled triangle. If you call this angle, or this side length, say x, and this side length 1, this angle here would be inverse tan x, and this angle up here would be inverse tan of 1 over x. And therefore, those two angles add up to 90 degrees, or pi over 2. And so what have we done here? We've shown that this derivative, this I prime of x, is equal to x divided by 1 plus x to the 4 times this constant pi over 2. So we had this function I of x, and now remember we're trying to work out what I of infinity is. And what we've done is we've worked out that its derivative, I prime of x, is equal to x over 1 plus x to the 4 times some constant. Now, let's take this onto the next page and we'll continue. Okay, so we have that I prime of x is this thing here, and what we're going to do is just integrate this to give us an alternative expression for this integral here. So I of x is just going to be the integral of this guy, so I'll factor out the pi over 2, and it's the integral of x over 1 plus x to the 4 dx. And now, well, this is quite nice because we can see that the denominator has a 1 plus x to the 4, and now that looks a bit like 1 plus x squared if x squared was, some other variable. And this is actually what we want to do, a little substitution here, because the numerator here is x, which is a scalar multiple of the derivative of x squared. So I'm going to say u equals x squared here. So then du is going to be 2x dx, and so therefore x dx would just be a half du. And so this integral here becomes pi over 2 times the integral of x dx, which is a half du, all over 1 plus x to the 4, which is going to be 1 plus u squared. And now this is a pretty standard integral. If I take the half out, this is going to be pi over 4, and then I'm left with the integral of 1 over 1 plus u squared, and that's just going to be inverse tan of u. And if I just bring back u as x squared, this is pi over 4 times inverse tan of x squared. And then, of course, I've got a plus c here because this is an indefinite integral. Okay, this is great. I get this result here that I of x equals pi over 4 times inverse tan of x squared plus c. Okay, now how do I work out what this plus c is here? Well, I need to work out, well, what is I of a particular value of x? And now what's a really nice value of x to choose here? Well, you could choose x approaches 0 or x approaches infinity, but in fact I'm going to choose x equals 1 here because then my lower limit and my upper limit are actually both the same, and so I of 1 is actually just 0. And if I of 1 is 0, if I substitute that into this here, I get 0 equals pi over 4 times inverse tan of 1 plus c. Now inverse tan of 1 is just pi over 4, and so then I get that plus c here is going to be negative pi squared over 16. And so what have I got? I've got that I of x is pi over 4 times inverse tan x squared minus pi squared over 16. So the very last thing we have to do here is just take x approaching infinity. Okay, so all we have to do now is take x to infinity in this guy. So this integral, if I just call this I, the thing we're trying to work out is the limit as x approaches infinity of I of x, which is the limit as x approaches infinity of pi over 4 times inverse tan of x squared minus pi squared over 16. The pi squared over 16 is a constant, so I'm just focusing on this inverse tan of x squared. As x goes to infinity, x squared is also going to go to infinity, and inverse tan of infinity is just pi over 2. So this is going to be pi over 4 times pi over 2 minus pi squared over 16. That's pi squared over 8 minus pi squared over 16 is just pi squared over 16. And that there is our final answer. So the integral from 0 to infinity of x times inverse tan of x divided by 1 plus x to the 4 dx equals pi squared over 16. And we didn't need to use any complex numbers. We basically differentiated and integrated again and used a couple of nice little tricks here. And yeah, we get the answer of pi squared over 16. I hope you have found this video enjoyable and hopefully have learned something from it. If you are new to the channel, please do consider subscribing and also giving this video a like as well. I'd really appreciate that. Anyway, thank you for watching. I'll catch you in the next one. Have a great day.